Well, hi, class, and welcome to statistics. First lecture, so I better do a good job so you'll watch all my lectures. Charity McKenzie here. And what is statistics is kind of this first chapter. What is a sample? What kind of data do we have? And then that's really what we're starting with. So it's a very heavy definition, chapter one. And then you move into like, well, now what do I do with the data and different ways to graph it and analyze the data. So statistics in general um, really is a collection of some kind of data and then analyzing it, right? And coming up with um, some kind of conclusion about your data. So as you're looking through my guided notes that I provide that I follow through on my video, you might see an extra question at the end because sometimes I'm like, oh my goodness, I should add this question. And I may not have done a new video yet, but for the most part, they should match for you lecture and the guided notes that you find in Canvas. So if you look, the key concepts is just prepare, analyze, and conclude. Basically, set up a sample, analyze it, and then make a conclusion. That's what statistics is. So data is a collection of our observations. So we could collect data in some kind of observation, like we watch cars drive by and we collect the colors or the brand or whatever. We could do where we make people walk in and step on a scale and we get their weight, their measurement, right? We could do a survey and ask people questions. So lots of ways to collect your data. Okay? Um, some are good, some are bad. We're going to talk more about data. Statistics is really, like we said, just collecting that data, analyzing that data. And then we go into like, what is a population versus what is a sample kind of idea. And this is a big concept for this section. So population is in your group. What are you talking about? So if I'm going to do a sample, if I'm going to do a population of everybody in Sheridan, if I want to know something about everyone who lives here, then that's my population. Okay. And then I might take a sample of that population and do an analysis of it. Okay. So sample, I could do that. Or I can get a census. And a census would be a collection from every single person in your population, which would be Sheridan. Oh, that'd be super hard to do, right? A census is really difficult. That's why we have samples. So this is easier to get, right? This is easier to get, right? Because your sample is just by far the easier thing to do. So another example could be like, I want to know about the math students at the college, whether or not they answer a couple questions on the math center or they use a tutor or if they contact their teacher or something like that, right? So my population would be math students. And then I might take a sample from maybe my class or somebody else's class or every fourth person that walks upstairs to the math area, something like that. Or I could get a census if everyone in those math classes answered my question, which would be an easier census than like everyone in the United States, right? Or even everyone in Sheridan. So census is everyone in your population, and a sample is just that subgroup from your population. So what you'll learn is a lot more on this sampling. And you'll learn like that is the number one thing I look at when I see somebody did some kind of statistical analysis. I want to know how many people were in your sample, how did you get your sample, and was it random? So you didn't just stand outside of Walmart and ask the first 5 people and call that good, right? So that's one location, 5 people, and then you say that's going to work for everybody, right? So we'll do more and more things like that, but you can see where we're going with that population in that sample. So here's an example, try to cover up my, maybe I'll just scroll it down. cover up my answer on example one. I have it there for you, but I don't want you to see it yet. In this journal article, residential carbon monoxide detector failure rates in the United States, it was stated that 38 million carbon monoxide detectors were installed in the United States. When 30 of them were randomly selected and tested, it was found 12 failed to protect and provide the alarm in a hazardous situation. Okay, so what is my population? Like, what is the whole thing that I'm looking at? It is all of these carbon monoxide detectors in the United States. That's our population, is all of those carbon monoxide detectors. What was the sample? The sample was the 30 that I randomly selected and tested. Okay. And I just wrote that down here, the population sample. So you have to be able to get that. And you can't look at the statistic. The statistic is the 12 out of the 30. It's nothing to do with the population and the sample. So you have a statistic in there that, eventually we want to do something with. But at this time, we're just looking at that population and sample. Okay, I kind of put in this little diagram here about preparing, analyzing, and conclusion, kind of give you an idea of the overall, how do we do statistics? Like, how do we set this up? How do we get that data? Then analyze it, and then conclusion. And that's what we're going to be working through on this whole first unit. Okay. So watch out for pitfalls. Okay, I just gave an example. I am going to say something about everyone in the United States, and I stand outside of Walmart and I ask 5 people, is that really a good sample? No, no, it's not. Okay, it's a convenient sample because I'm conveniently standing outside of Walmart, and it could be misleading or have a pitfall. So we could have misleading information and we could have bad samples. We could have a lot of things go wrong in statistics. That's why there's a lot of stats out there that are wrong about things. And not that people meant for it to be wrong. They had good intentions, but that it just may not be, it may be a little misleading. So you could have a misleading conclusion, just you're reading stuff wrong, something like that. You could have your sample data is reported instead of measured. Great example. Let's ask all the girls at the college what they weigh. Let's just ask them what they weigh, right? And then let's put them on the scale. And what would be the difference? You're darn right, I'm going to lie about my weight. I'm not going to tell you how big I am. No, no, no. So you can see that, like, definitely a difference between stated and actually measured. Okay. Loaded questions. So if you're doing like a question towards some kind of survey, you could load it like the first question. Usually they'll answer like more, they're more on it to answer that honestly and will actually answer it. And as you get further along the survey, they're getting bored or whatever. They don't want to answer questions anymore. They might just be guessing or, A, B, C, D, just putting in whatever. So loaded questions also could be you're leading them to what you want as well. Lots of ways. Order of the questions, I just said. Non-response is huge. And percentages. Some studies cite misleading percentages. Note 100% is everything, right? So if I told you I gave 110% on this lecture, was that even possible for me? Well, no, I can't give you more than what I have to give. 100% is everything. So no, you can't give more than 100%. So that could be misleading. There are cases where you could use a percent of 200. That means it doubled. So I don't want to say like all over 100% is wrong because I could be like, oh my gosh, I got 200% of last year. It doubled my people who maybe bought something from me or something. Okay, so you can kind of see all this pitfalls in analyzing, and I'm hoping you're thinking about that. Think about the news and think about all the different news sites reporting the exact same thing and how misleading you can find some of the stuff and how different. And those conclusions are so very different from one site to the other. So we can see that misleading. So let's go a little bit different. When we're making a conclusion about something, we have statistical significance. So this is the idea that whatever you came up with, your conclusion from your data is not possible by chance. And it says that they use 5%. Now that's our book and our author. That could be a little bit different depending, and it could be some gray area there, but it's like for the most part 5%. So the statistical significance is achieved in a study if the likelihood of the event occurring by 5% or less. Okay. So here's my example to kind of help you wrap your brain around statistical significance is if I'm getting 98 girls out of 100 births, that is statistically significant because such an extreme outcome isn't very likely by chance. Okay. If I get 52 girls being born out of 100, that's not statistically significant because that could easily happen by chance because it really is equally likely to have a boy or a girl when you give birth to a baby. So 98 out of 100 is really out there and it's statistically significant. So think about it. Another way to think of this. If I give you a medication for weight loss, right? And I give you this medication and you lose 5 pounds, is that statistically significant? Well, you could probably have lost 5 pounds easily on your own. What if you lost 100 pounds, right? Like it could be, well, I guess it depends on how much weight you need to lose and what you weigh, but just overall, it's just something that can't happen by chance, less than 5%. Okay. My weight loss it might not be the best example. Just weight loss medications are huge right now, right? So if that person tried for a year and lost 5 pounds, and then they tried for a year and they lost 100 pounds and they weighed over 400 pounds, that is statistically significant in favor of that weight loss medication versus on your own. Okay, practical significance is a little bit different. It is possible that some treatment um, is effective, but common sense might suggest that that treatment or finding does not make enough of a difference to justify it. Practical significance. It's like I gave you this, but it's really not showing that big of a difference. It's practical. So common sense suggests that it doesn't make enough to justify it. So maybe they give you a medication to say you're going to have a baby girl, and you have to give it to the male because the male's part of the baby is what decides the sex. So if you give this medication to a male and you're getting all 52 girls, and everyone wants to have a girl or whatever, it's not. It's showing you like 52 out of 100 is a little higher than 50%, but it's practically your brain is telling you that could have happened, right? Naturally. All right, those are not easy to look at. Let's look at a couple examples here. Example one, why do we use a sample more than a population? And you're welcome to pause this video, try to answer this, and then come back. Like I probably would make you in class, but really a sample's just easier. There's no way around it. To get a whole census of the whole population is really hard. So a sample's just easier. I don't feel like I need to write that out. You can write it out on your note packet if you so desire. For part two, or question two, it says, for the following, is the data set a population? Oh, for the is the data a population or a sample? I'm not getting that out very well. So question two, the make and model of every car in a school's parking lot. So I'm looking at the make and model of every car in a school's parking lot. Is that a population? Does it have everything, or is it a group, a sample? Well, they say every car, right? So when I say every car, this would be a population. Okay, the number of children in every other home in a neighborhood of 200 homes. Is that a population so you have everyone, or is that a sample? That's a sample, right? Because we just said every other home for one of the 200 homes. It was a group from it. Question 4. The number of pets for 10 out of 200 homes in a city. So we surveyed 10 out of 200 homes. Is that a sample or a full population? You should say that's a sample. I got 10 out of however many. 5. The number of bedrooms in every house on a neighborhood or in a neighborhood, should say in. Every. So I'm saying every, all population. Okay, so we're looking at just is something all, is something, just a group. Next group of questions. List the population in the sample for each of the following. I did a study of 3,000 adults in Sheridan County, and I found that 20% are going to get chickens this spring for cheaper eggs. Okay, so I did a study of 3,000 adults in Sheridan County. 20% are going to get chickens this spring. What is my population? Okay, this would be what's the name of the group? Well, it's the adults in Sheridan County. So this is our it's adults in Sheridan County. Okay. So my U kind of looks like an R. Okay, so that's our population. What is our sample? Okay. Our sample is we did a study and how many people were in that study? 3,000. So it's the 3,000 adults that we did the sample of. Adults. Okay, so the population is kind of the title of whatever you're talking about. The sample is usually a number of so many people. Okay. Question 7. And again, pause, try this, and then see what I say the answer is. A survey of 1,000 women in a particular county found that 47.5% received a influenza vaccination for a recent flu season. When I look at this one, what's the population? And it can be very vague. It's just women in a particular county. That's it. That's all we know. Sometimes it's just like all adults, all teenagers, all children. And that's all, because that's what we're talking about is these women in this whatever these are. These women in whatever county. Oops. I have country, not county. I was thinking county because we did the one before, but this one has an R, so country. So women in this particular country, and then what would have been the sample? It would have been the 1,000 women that I asked if they got this flu shot. What is the 47.5? It is a statistic. It is about your population or your sample. You took the sample and you got that information of 47.5%. Okay. Question 8. A study of 1,000 adults shows that 5% of the adults still have a home phone. That's probably in Wyoming, from all the rural areas where they can't get cell service. So a study of 1,000 adults. What's my population? So my population would be all adults. Here's one that's very blank, right? All adults. That's what we're talking about. Adults. And what was my sample? It was the 100 adults that I pulled. Okay. 5% again is a statistic, so it doesn't have really anything to do with what we're asking yet. But some point you might have to find that or say stuff about it. But for now, we're just focused on this part. Okay, Is there a bias in the following situation? So bias like that makes you lean a certain way. So let's look at 9. A certain medical organization tends to oppose the use of meat and dairy products in our diets. And that organization has received hundreds of thousands of dollars in funding from an animal rights foundation. Is there bias there? Okay, well, they're opposed to meat and dairy in our diets, and they just got funding from an animal rights foundation. Of course, that's kind of in the favor of both of those. I don't really have another context, but it's definitely in favor. Now, I mean, we could add more questions, but definitely a potential issue there because you're getting the money from here. Um, all right, let's look at the next one because it's a little bit better. But at Sheridan College, I obtained the amount of money each student paid for books and supplies. What are some potential biases or issues from obtaining the amount of money from each student? So, first of all, we asked every student. That's not bad. It's not super biased. Okay. If I would have only asked maybe the science-based, science books are very expensive, or the nursing, those are all science-based books versus maybe arts or history. Those books typically aren't as much money. Some might be, and I might be lying, but now you do these online subscriptions, so it's a little bit different. But typically, those are a lot more money. That's not a bad you could still come up with some potential issues with that. Uh, but I don't know. This one's not bad. And that's because we got each one, each person's amount of money that they spend on those books and supplies. But it could be just their degree. That could be a pitfall or a potential issue is their degrees are different. Maybe arts, you have to buy your own supplies, could get really expensive. Maybe if you're in diesel, maybe you you have to purchase a vehicle to fix up or something, so that could get really expensive. Um, I'm going to add just another thought on that. What what biases would you think there'd be if I stood outside of Walmart and asked questions? First of all, it's you're not going to get a chance of everybody because not everyone shops there on that specific day, especially. But not everyone shops there in general. So it's not an equal sample. It's not equally likely. You could also get people in a hurry and they don't answer your questions very, very well. Probably don't read them, the questions carefully, things like that. Okay. Um, all right. Determine whether the following results appear to have statistical significance or practical. Okay. In a study of weight loss program, 7 subjects lost an average of 25 pounds. It is found there is about a 25% chance of getting such results without a weight loss program. Okay. Um, so 7 subjects lost 25 pounds, and it is found um, that 25% chance. So, does this have statistical significance? Well, there's a 25% chance of getting this result without this program. So, it's not less than 5%. So, there's no statistical significance. So, no statistical significance. But does it have practical significance? Well, yes, I think it does. Obviously, the program's working if 7 people lost an average of 25 pounds. So practically, yeah, like it could work for me, and maybe not Johnny over here, but maybe that program could work for me. So I'd say, yeah, my logic says that, yeah, it could be working pretty good for some people. So, yes, on practical significance, but not necessarily statistical. Oh, super wordy question, Charity. Okay, the medical college admission test, MAC, um, it's commonly used to as part of the decision-making process for determining which student um, to accept into a medical school. To test the effectiveness of this preparation course, 16 students take the I think that's what it's called, MCAT. That's better. Test. Obviously, I'm not a doctor. I'm a math teacher. So MCAT test. Then they complete the preparation. I can't talk. They complete the preparatory course, and then they take the MCAT. Okay, so some people just take the MCAT. They just take it, and some people take a course to prepare them for their MCAT. Okay. With the results that the average mean score of the group rises from 25 to 30, there is a 0.3% chance of getting those results by chance. Does this course appear to be effective? Okay, so we went from a 25 to 30 when we did the course. That's great. And they say super small chance of getting a 5 points more. I don't really know how this scores because I'm not, like I said, not a doctor. Um, so it's super hard to do that. So that is statistically significant as well because it's not even going to happen by chance because they say it's this percent and that's lower than 5. So this has um, statistical significance. I can't say half the words, but like in my brain, I say them right and then they just don't come out right. Does this also have practical significance? Does it make sense to do a preparation course? And yeah, so I would say it has that as well. Like in my brain, I'm thinking, yeah, that was helpful. So I would say it has both statistical and practical. Oops, that should be 1A, significance. So it's both practical and statistical on that one, I feel like. Okay, so that is just some questions that I had to kind of help you with what your homework's going to look like. So again, big homework on what's the population, what's the sample, and kind of like analyzing whether something's a good idea or not, and looking at that kind of biases. All right, good luck on your first homework.